stars are falling, I feel alone. When the stars are falling, I feel alone. When the stars are falling, I feel alone. When the stars are falling, I feel alone.
What's up, hackers? Welcome to Chill Code. My name is Taggart, and tonight I am back on one of my frequent kicks, which is eBPF. And we're going to be writing a little bit of eBPF code tonight, or trying to, at least. This is going to be me flopping around like a Goldine in the Linux kernel. And so hopefully you will learn something from it. I know that I will, and I'll have a lot of fun doing it. If you're not familiar with eBPF, you may be familiar with its forebear, the Berkeley Packet Filter, also known as BPF. And this was a syntax to do high-speed network packet filtering using the Linux kernel. Yeah, Goldine Thief. I came up with N64, so I think a lot about, when you got the Goldine Pokeball. So you may be familiar with the Berkeley Packet Filter in that context, but since that time, the concept has been taken and expanded to not just network packets, but all levels of the Linux kernel. So there are probes for the entry and exit into functions, for access of syscalls. Basically, if the kernel does it, you can hook into it with BPF. And here's the thing. eBPF used to stand for the Extended Berkeley Packet Filter. It now stands for nothing. It just is its thing. I don't know when that happened, but it happened. So basically, we're not talking about packet filtering anymore. You can do that with it, but it's not an acronym anymore. It's just a bunch of letters that are a name. So here's how it works, basically. This diagram could be better. This one's a little bit nicer. So basically it goes like this. Anytime something happens in the kernel and there is an eBPF program that is hooked into that kernel event, that eBPF program will run and do its thing on its way to the syscall or the function entry or exit occurring. Now, the way that you write these programs is a little bit tricky, because eBPF programs are written in a subset of C. Not my favorite, but they're written in a subset of C, and they are compiled into eBPF bytecode, which is then loaded into the kernel dynamically. And that's a big deal. Not too long ago, it wasn't really possible for you to dynamically add things into the Linux kernel during runtime. You'd have to recompile it, or at least restart the computer and reload the Linux kernel. That's not true anymore for a lot of reasons. Things like the dynamic kernel module system, DKMS, and also things like eBPF. You can load things into the kernel at runtime, and that means we have this capability. But because it's the kernel, because we're really working with radioactive material here, right? This is like as low down as it gets into the operating system. We have to be careful. So the reason it's a subset of C is that not everything is allowed. So for example, there are no infinite loops. There's no like while true in eBPF code, because there's no guarantee that it's safe. In fact, it's by nature unsafe, right? So there are certain things you can't do in eBPF, and there are some functions that may not, or some libraries that may not be available to you. So that's something to keep in mind. But then there are other things that you can do that are built in, like saving global variables and creating what are known as maps, key value pairs of data that your eBPF program and other eBPF programs can access running together. So that's kind of cool. So there's a lot to this, and I am definitely still learning a lot about it. There are a lot of tools in a lot of different languages to learn about how to write this and help you write it. Obviously, I want to eventually start writing a bunch of eBPF programs in Rust, but that is not going to be what happens tonight. This is a Rust-free stream. You have my word. There will not be any Rust that appears. That might be going too far, but we are not intentionally going to be programming in Rust tonight. Tonight, I think the most complicated stuff we'll be doing is the C that we have to write for eBPF, and maybe a little bit of Python, because there is a really nice tool called BCC that allows you to write eBPF programs in Python and then have the C component, the BPF component in C compiled right along the way. So we'll be using some of that. if you're interested in getting started with any of this stuff, the stuff that you're going to want to have installed, you're going to want BCC for sure. You're also going to want to have BPF trace and the BPF tools installed in a Linux machine, a modern Linux machine. So I'm using my KDE Neon virtual machine that I use for development, and I have all of these tools installed. So you can play along with these. A lot of them, one thing that's really cool is that there are a lot of pre-built BPF tools to show you how it works and give you a lot of ideas about how to build these kinds of tools. Hey, Hammerhead, thank you so much for the follow and for the sub. Really appreciate that. So these are kind of cool. BPF trace is one of my favorite things in the BPF universe because it's like strace, but using BPF. And there's a great one-liner tutorial that kind of goes through how it works. So BPF trace has its own, it's almost like an awk syntax, right? So it's C-like, but it's kind of like a subset. It has some interesting capabilities, and it is its own language, right? And so you can write programs in BPF trace instead of writing them in C, and then pass them to BPF trace as an interpreter. And that can be one way that you can write some of your BPF programs. It works pretty well, actually, for a lot of the things that you might want to do, as long as what you're monitoring doesn't have to be immediate. And you'll see what that means in a minute. So, for example, let's take a look at one of these. I want to show you TCP Connect first, because that's a BPF tool. Yeah, TCP Connect BPF CC, please run. Okay, cool. So it's running. Now, TCP Connect BPF CC is the compiled version of this BPF tool. And it failed. Cool. Great. Does the BT version run? Maybe. Interesting. No. Character constitute log for a site. Alright, I guess I'm not showing you TCP Connect. Let's try file opens. Let's just make sure this works. And you'll notice that I'm running as root because by its nature, BPF has to run as root. Okay, so BPF programs do work. For whatever reason, that one didn't, which is kind of interesting. Huh. Interesting. I'm curious what that problem was. Failed to compile BPF module %s source file. Interesting. What an insane error. This looks like I'm missing dependencies. Maybe I need those libraries. That's very odd. It's almost like there's a problem with the tool. Let me go grab them from Git, just in case there's anything better there. Yeah, because we have libbpf tools right here. So we'll go pull these, just in case they work better. Which I apparently already have. Golden Ratio, thank you so much for the follow. Well, we're off to a great start. I'm going to straight up look this up, because I think this is probably a common problem, and I want to know what it is. Yeah, show me what's up. Oh, interesting. Compiled using 0.24 using the source code on Ubuntu 22.4. It works fine. The 18 version installed using apt install BPFCC tools has the above compiler error. There you go. Finally, it works. Built from 0.25 release. Will cheat for Ubuntu. Uh-huh. So we're going to fix this. We're going to get them running. That's a nice cheat sheet. Thank you, GitHub. So, when I said the BCC was the first thing you were going to want, I was not far off. How's everybody's week going? Heard from Thief of Always that they had a very successful set of interviews. Prax, you missed nothing. We're setting up dependencies. Good to see you. All right, so we have BCC. Source the submodule. Git pull recurse, right? Submodules. I can't believe I remembered that. Okay, and then yeah. Kieran installed a new motherboard 2 weeks ago. Troubleshooting instability issues, poster image. Oh, it's the worst. Oh, I hate that feeling, Kieran. When you've invested so much money in a piece of equipment and it's like it feels flaky or it doesn't work at all. Oh, that's the worst. I am sorry that you're dealing with that. I mean, whether it's the board or if it's, you know, a conflict between the board and some other piece of hardware you have, now it's like you were excited for the thing, and then that all gets soured by the extra work that you have to do. Ugh. Boo. So, one of the things I put on Twitter today, I'll admit, I was a little distracted today, so I was on the bird site more than I should have been. But one of the things I put was this BPF trace command. And this thing works a treat. Let me fire this off. It's like, what is it? Sudo BPF trace. Yeah. Oh, finally it pastes. Wow. What a delay. Okay, this is like seconds of delay. That's crazy. presumably because we're building CMake. So this is a little bit tricky to read if you're not familiar with Kieran. How come the terminal adds those weird characters when you paste on the clipboard sometimes? Those weird characters are actually in the clipboard text in my case, because I delineate, or I delimit shell commands with backticks. So no, those were there by my own hand. Prax reran the poacher command in and it worked. Oh yeah, Prax and I were troubleshooting a poacher command. I'm not surprised that it worked after dinner. Not because with a full stomach your computer works better, but because when I was looking at the error, Prax, it looked like a momentary network hiccup, right? Because it said the SSL connection timed out, which seemed like something was going on with DNS or something like that. And so it's not surprising to me that a rerun did the trick. So what is this command saying? First of all, we're using BPF trace, which for all intents and purposes is it's an interpreter, right? It allows us to do BPF stuff without having to go through the trouble of writing full out C programs. So that's really cool. Now, the expression, because you can write BPF scripts, right? .bt files, and we'll take a look at some of those. But for now, what we have is this expression that we're writing in line. And the way that BPF trace expressions go is you start with the thing that you're hooking. And you can either use kernel probes, you can use syscalls. There are also function enters and exits. There's a bunch of stuff that you can go get. And in fact, BPF trace will actually help you list out the things that you want to, that you can possibly hook into. I am using a kprobe, a kernel probe, for the TCP connect event or syscall, right? And now I have access to all sorts of stuff going on for any of the calls here. It's a kernel function call, right? So any of these TCP connects, I have access to variables that are built in that I can use to write my script. If we go to the BPF trace reference guide, which is very well written, it will not only explain the language of BPF trace, but also tell us a little bit about the kernel level probes, right? Trace points and variables. So the built-in variables that you have access to for any of the things that it's tracing are the process ID, the thread ID, the user ID, the group ID, number of nanoseconds elapsed, all sorts of cool stuff, right? The process name, and then there's also very often arguments. So arguments to the traced function, if it's a traced function, are named arg0 to argn. And then stack arguments as well. So you really have a lot of crazy abilities with this. Okay? Now, that's to get started. So what we're doing here is this is to track any use of TCP by not regular users. And so my thought was, after this weekend when I was running a honeypot, the honeypot was designed to compromise the web server user, right? www-data. Well, the user ID number for www-data, and basically any service account on a Linux machine, is under 1,000, at least in Ubuntu world. And I think it's under 500 if it's for some other older distributions. So if you want to watch for TCP connections from service accounts, then what you would do is set up this kernel probe, right, on TCP Connect, and then if the user ID is less than 1,000, because you can write conditionals based on that user ID, what we're doing here is we're creating a summary of all of those events counted and grouped by their user ID. So there's a lot of eBPF coolness going on in just this single line. What's going on is we're using what's called an eBPF map, which are global key value pairs that BPF keeps track of for us, and we can assign values to. And so that's why we can set things up by the user ID. So let's run this, I hope, even though I uninstalled a bunch of eBPF stuff. I'm curious. eBPF Trace isn't found. We have to reinstall all of it. That's fine. So we'll go do that. Right? Okay. And then we've got to build. Okay. And then we're gonna... Oops. I do that too much. I do Control-Shift-C in the browser because I'm so used to doing Control-Shift-C on Shift-C on the terminal. Nice. And then make. And what does check install do? I should probably know that. Track installation of local software. And produce a binary manageable with your package management. That's neat. So what we're doing is we're compiling the BCC stuff from source. And the reason we're doing that is because we want to have all of these capabilities. We should also probably read the install for BPF trace. Ubuntu. Snap, also available as a snap package. This seems like a bad idea. But I don't want this older version of BPF trace. Is there a release? There is. Is there a package? No. Nor would I expect there to be. Boy, I gotta give this thing more juice. How many processors did I give this VM? 3 and 8 gigs of RAM. So it's not, I mean, I could do better, but... All right, while this is cooking, let me see if I can get BPF trace going elsewhere, because I have it installed elsewhere. At least I thought I did. Didn't expect to have to be compiling source code tonight. At least not the entirety of the BCC library. Okay. Let's see if I can get this working in Windows Subsystem for Linux. Hey, GoPro. Good to see you. Attach one probe. I don't know if it's going to do much. All right, so now I have to do something with TCP as a UID less than 1,000, right? So if I just curl, right? So now I've done something. Oh, it did work. Despite the fact that there was... That's so funny, the K-headers wasn't there. But nevertheless, notice that what I got was this 0, 2. So I had 2 TCP connections. That was the BPF trace doing its job, tracking those TCP connections that I made. Now, it's not particularly special here, but notice that if I had, if I cat etc password here, if I had seen a connection from, something like www-data, that would have been alarming. And in fact, that may be a specific thing to watch, is the user ID for your web server. And if there's anything kicking off there that you don't think should be kicking off, then definitely call it out, right? Paperboy Gold asks, how does this thing insert into kernel processes without disrupting them? That is a fantastic question. And the answer is that the eBPF runtime is running as part of the Linux kernel. And yes, sort of a sidecar, it is a subroutine inside of the kernel that is handling stuff in its own queue. Yeah, so basically they're almost like valves in a plumbing system. So as you get to a syscall, right, if there is a hook, if there's an eBPF hook, then the information is passed over to that eBPF, the just-in-time compiler, then passed over to your eBPF program to do its thing. And then any data that is returned from it is sent to the eBPF maps storage, and you continue along your merry way. That's pretty much it. It's not that different than a non-blocking debugging breakpoint. It's just that information is shunted, not even shunted, but almost copied from the run of the kernel execution over to the eBPF program, so that you have that information as well. Yeah, if you want to know more about how this thing works, this is about as good as it gets. Wow. Okay, so... where did this thing put anything? User share BCC tools. Ah, that's stupid. Python, no such file or directory. Wow. Well, this is annoying. Python is Python 3. That should solve that problem. And indeed it does. Check this out. We've got our TCP tools working. I'm going to have to reinstall BPF trace, I think. Like recompile it so that we can use it. But our BPF, speaking too quickly. The BCC tools are now installed and working. I'll have to add this to our path, right? User share BCC tools. But other than that, I think we're good. Now, I'm not doing anything, but for sure TCP connections are happening. And this is the kind of default tool. Now, as you can see, this one's actually showing stuff to me in real time as I make it happen. It's showing me the command, network manager, Chrome child, source address, destination address. So it is doing essentially, you know, packet capture kind of work, but it's giving me a nice table here. And that is kind of cool. You can see there's curl doing its thing. Now, the trick is that these BCC tools are built with performance in mind. Performance monitoring, mostly, is what it's built with in mind. So for that reason, as security professionals, we may have other things that we want to do with BPF, and that's kind of what I want to investigate. There's some crazy things that you can maybe pull off with this. And the reason I know that is that we already have a tool that is in production that is built with eBPF for exactly this purpose. Sysmon for Linux, it turns out, is built on top of the eBPF technology. The way that it works, it's like right there, right? The way that it works is by using eBPF to hook into what's going on in the kernel and then creating the sysmon events that we're used to seeing in Windows, right? Process creation, process termination, file writes, network connection, and DNS queries and config changes, I think is all that it's doing right now. Obviously, there are some sysmon event IDs that just won't make any sense in Linux, like registry changes, or actually even process access, I think, is going to be a little bit different in Linux, because there is no such thing as create remote thread or get process handle. Okay, so how do we install this for real? I don't want to install it. I want to build BPF trace. Okay. I believe we've hit all of this. Okay. Flex, G++, Git, yeah. Make-J and proc is more correct in a README, I guess. Yeah, I think that's right. That's just a little bit of copy pasta right there. Good catch. I wouldn't have seen that either, GoPro. Man. Great band. Yeah. Okay. Ooh. There are a couple of things that I didn't have, like cereal. You know, one of the things that's interesting about this to me is that I'm, interacting with the C development environment, right? And I hate it. I understand why it is the way it is, but coming from much more modern build systems, it feels so crazy to me. Right? I don't have cargo, or I don't have any other sorts of package managers or helpers to figure this out. You're making folders and you're reliant on the make file. Totally crazy. We're also going to need the LLVM stuff. All right, you know what? Let's drop into Bash here. Just make sure everything that we need is there. Figure out your own dependencies. Exactly. I don't want to do that. I want something much smarter than me to figure out my dependencies for me. Especially when you get into things like LLVM. That was a nightmare, by the way. Oh, man. When Husky and I were trying to figure out how to do the cross compilation for macOS for Offensive Notion, figuring out the right LLVM versioning and how to get the right variables to that version of LLVM, utter chaos. Because you have to have two versions of LLVM installed next to each other and running essentially at the same time. That was unpleasant. LLVM, by the way, I don't know if I can really do a very good job explaining it. It is essentially the tool with which compilers are built. It is it's a tool designed to build compilers, is what it is. So it's a set of ways of parsing languages to build machine code, and everything uses it. Of course, it's a GNU project. I think. I just took a look at the website, and based on the way that it looks, or is it its own thing? It is its own thing. It is not a GNU project. That's awesome. Huge fan of it not being a GNU project.
You've been in the hell. You've been in the fire. You've tasted corruption. Depart from me, you cursed, into everlasting fire, prepared for the devil and his angels.
Let's go check out some of the other one-liners. File opens are cool. This is a fun one to see. So again, we can use BPF trace. And for this one, we're going to run on a syscall, and the syscall is sys enter open at. So this is not the open syscall. It's very specifically the entry of the open at function. And this will create, this is going to be a print of the command in the string arg. So anytime a file is opened, trace point not found, syscall sysenter open at, or not. Well, let's see, sudo eBPF trace L trace point syscalls. Capital L. Does it care about the single double quotes? I can't imagine it does. Wow. What trace points do I have? What? Welcome to WSL, I guess. I have software and hardware. End of list in WSL. Interesting. Okay, all our stuff is built here, so now we can maybe finally build. What the? Wow. On LLVM 11. This file does not exist. It's looking for LLVM 14. Let's give it all of the LLVM 14 stuff as well. Because like I said, LLVM is a nightmare. And that's exactly what we're running into right now. I love it when the documentation doesn't match. That's really cool. Well, how do these Kubernetes people get it done? Because if all of this tooling is out of date and all this documentation is out of date, how do they make this work? So chat, one thing I do want your help with is some brainstorming. What are some things that you think this kind of technology might be cool for from a security point of view? So the idea that actually kicked this off was thinking a little bit about how you could get data out of a malicious SSH connection using eBPF. I don't know if that's possible, but that was kind of the first idea I had. But that's the idea you're thinking about. So in like automated response or deeper monitoring than maybe you could do with traditional EDR. Like Linux endpoint detection and response software sucks. And one of the reasons is because it's not doing this. Imagine you could go as deep on Linux into the kernel as you can with Windows Defender on Windows. What would you want to do? What kinds of things might you be looking for or try to detect or try to prevent? Or on what conditions would you want to terminate processes? Basically, I'm thinking about ways to make the environment hostile to attackers, like actively hostile. There's libclang. Archon, thank you for the follow. This file does not exist. Okay. I'm going to just try to install BPF trace now and see if we can get it working with the newer version of the BPF tools that we've installed. Maybe. Oh, there's libppfcc. Errors were encountered. So no. So package. Oh, interesting. Boy. I done messed this up pretty good. CMake error, user lib, LVM, select targets, import target ceiling back to the first file. Select basic A. This file does not exist. Possible reasons include. Okay. Let's see what this is about. Oh yeah. Well, let's see if NeoVim users fix this. No. Oh, is that it? That's it. That's why. We need that too. Which should have been listed. Fix. I actually don't want to do that. I want to see if I can build it this way. Okay, just kidding. Guess I am installing it this way. I actually don't want to install. I just want to fix broken. Oh boy. Jeez. So again, what happens is we try to unpack libppfcc, and then trying to overwrite, which is also in package build to 1091. I think check install messed us up. For sure somebody else has had this problem. So the issue is... How do we remove a check install package? Yeah, here we go. How do you uninstall a package locally installed with this? Make uninstall? Is that it? So if I go... Almost an hour in, we haven't done jack. CD build. CD make uninstall. That actually might do the trick. Apparently not. Here we go. I don't believe that I am trying to overwrite libc, Paperboy. Well, we're learning. That's for sure. A lot about how to not use C compilation options. Okay. Okay. I think I know how to do... I think I know what we need to do. Sudo... The name is build. That's dumb. Oh boy, we're in a bit of a loop. Okay, here we go. Here we go, here we go, here we go. Alright. Now, here we go. So we're removing build. And now we install Does this work? It does. And we're getting the old eBPF CC again. Okay. Now, do BPF trace things work? Yes, they do. Without errors, I should mention. Good God. Okay. So, with that done, so GoPro's asking what in the world is the @02. So, what we're looking at here, actually, check this out. Let's do this another way. Let's run that probe again, and again. So what we're doing is we are attaching a kernel probe to TCP Connect. If the user ID is less than 1,000, then we're going to begin creating a BPF map of user IDs, and we're going to count the number of connections. Hey, Husky. Happy 15 months. Good to see you, and I hope the engagement's going well. Right, so we're attaching one probe. So again, we'll do that curl. And then, since we're root, let's... who else do we have in here? Let's become... Oh, perfect. Let's become www-data. Or not, because it's got user bin no login. Oh. Or just Vim. Let's see, password, I guess. Yeah, let's, okay. Yeah. Okay, now. There we go. So now you can see that there was a TCP connection by ID 0 and a TCP connection by ID 33, which is www-data. Now, yeah, good call out, GoPro. I forgot that you could do that. Put that back. Anyway, so you can see that there is a user ID of 0 with one TCP connection and a user ID of 33 with one TCP connection. Now, that I tried really hard to find a useful way to add the user ID. And there is a function called getPWUID. However, I am not certain that it is available easily inside of BPF. I may have just written it wrong. And what this would do is you can actually go reference the password file and look up a username based on a user ID. That's kind of its whole idea. But, as I said, I haven't been able to pull that off just yet. So right now we're locked into user IDs, but there should be a way to turn these into usernames. So other stuff that we can do. Again, one of the things that I like to start with BPF is if we use BPF trace and -L, it'll list all of the hooks that we have. And so if you look for K probes, the kernel probes, These are all of the kernel probes that we have access to. And the things that kernel probes are dynamic as opposed to static syscall locations. Look at how many of them there are. Right, we use TCP Connect. They're also not alphabetical for some reason. Now they are. Right, all sorts of stuff, and including syscalls, like old syscalls. Lots going on here. USB actions might be interesting. Imagine doing DLP with eBPF. I should mention, by the way, that there is such a thing as eBPF for Windows. It does exist. Thing is, near as I can tell, it is pretty much limited to network hooks. I do not think that it goes any further than network stuff at the moment. And probably ever, right? I can't imagine writing the shim between eBPF and the NT kernel, the Windows kernel. So, obviously there's a bunch of stuff here. And so in order for you to, like, really know what you're looking for, it might be helpful to have some familiarity with what's going on in the Linux kernel, right? And so you can learn that a bunch of different ways. One way that you can do that is just writing some simple scripts and tracing them. So if we... let's just write a simple script, right? Okay, just by running that simple little tiny baby script, all of this stuff happened. How crazy is that? But what's cool about this is now we have some ideas about what we might want to hook into when things happen in the system. So strace, right? If you're not familiar with strace, incredibly cool bit of kit. Trace system calls and signals. The S would be for system. There's also an ftrace, which apparently is not installed by default. There's BPF trace. I thought there was an ftrace. Am I thinking of ltrace? I am. Library call tracer. Yeah, ltrace is looking for dependencies. Free agent X. Yes, thank you. ltrace. I swear there was an ftrace at some point. But the good news is that BPF trace will actually do that. And what I'm thinking about function enters and exits, but strace also gives that to you as well. So check this out. So we have execve is our first system call, a break, right? An access and open at, which we saw in some of those kernel probe examples. Close. What is getting opened, right? Current working directory. fstat. Mapping some memory. Getting some shared libraries. reading some stuff. There's a lot that goes into executing a simple script. No? And we haven't even gotten to the part where we echo anything yet. That happens here. So here's where the script is read in. And then this is the write. And what are we writing to? What is this number 1? Those of you who know, definitely go for it. But see if you can wait for somebody to maybe take an educated guess. When we are writing, yeah, I thought you might be. Go, bro. That's why I said, give it a second. When we're calling the write function, what is this number 1? What are we writing to? Absolutely right. Husky, standard out. File descriptor 1. Exactly. File descriptor 0 is standard in, 1 is standard out, and 2 is standard error, which, by the way, pen testers, you should know this one-liner, right? Find perm 4000 dev null, but you may not know why this part is so important. What's going on here is that we are redirecting file descriptor number 2, also known as error messages, to dev null because we don't want to see them. There are going to be a ton of error messages when we, from an unprivileged user, run find against the root of the file system, and we don't care about that. We just want to see what it finds. Therefore, we are redirecting the output from the standard error. Even though standard error shows up on the terminal, it's output to a different file descriptor, number 2, and therefore we're sending that elsewhere rather than to our terminal. Okay, so yeah, all that cool stuff. We just learned so much by running strace once. That's why this is kind of cool to me. Okay, so basic stuff. Well, it's not. This is, you know, it makes my head spin, but at least at the level we're at, the next fundamental thing is when you are calling commands, execve is the syscall at issue. And so, if we look at BPF trace and we look for anything with execve in it, we have some options. We have some K probes, x64 sysexecve, but we also have some trace points, and I think for our purposes, this is the more appropriate thing to do. And the question is, like, do we want to check, we want to, at first, watch any command execution of anything by, say, root. GoPro is redeemed playing me a song. I honestly didn't see that coming tonight. I can do that. Oh, man. With my new phone, too. This will be interesting. I believe this is a much nicer camera. Oh, that's so funny. I accidentally zoomed it all the way in. Okay. Alrighty, let's get you a song, GoPro.
Sound check. Hopefully everything's sounding okay. What do we want to do tonight? Let's see. Oh, you know what? We'll do if I have it. Yeah, this is a fun, sweet song. This is called East Harlem by a band called Beirut. Another rose wilts in East Harlem, and uptown, downtown, 1,000 miles between us. She's waiting for the night to fall, let it fall. I'll never make it in time. Another rose wilts in East Harlem, and uptown, downtown, 1,000 miles between us. She's waiting for the night to fall, let it fall. I'll never make it in time. The color I know. Sound is what keeps me looking for your eyes and the sound of your breath in the cold. The sound will bring me home again. The color I know. Sound is what keeps me looking for your eyes and the sound of your breath in the cold. The sound will bring me home again.
Okay, song delivered. So, now... Right, so trace points, syscalls, enter, execve. So what we're going to do is... we're going to fire this up. We're going to fire this up first in a script. And... do we have the BCC tools installed now? I can't remember. TCP connect. We do. So check this out. If we vim which TCP connect.bt, check it out. All of these are actually BPF trace programs, which is what we're going to write. So over here, we're going to vim execdemo.bt. Right. And we'll do a begin statement. And this is kind of how this works. I'll even do it in the appropriate C syntax, even though I really don't like this format. And we'll do a printf to say beginning command detection. Okay. And then you can see that there's this section here where we write our program and we hook into the specific thing. So we were looking for syscalls. If I can spell syscalls, enter execve, I think, and we'll fix that when we get out of this. Sys enter execve. I knew I was missing something. Sys enter execve. Trace point, and it's trace point. So trace point, syscall, sys enter execve. Perfect. Just like so. And then going back to our example, the way that execve works is that we'll have access to the command and any of the arguments. And the way that we saw the arguments work, right, was if we, let's run this again. So if we do trace echo high, right? If we look for the arguments to execve, it goes command arguments. And so we may need to destructure this a little bit. But let's start simply. Right? So we'll say command, and we'll printf. And let's do user space. So we'll use that if UID is greater than or equal to 1000, right? It's killing me to write in this format. And give it arg0. Do brackets really need their own lines? It's stylistic, but when you're writing C, especially ANSI C like this, you're supposed to do it. I despise it. I do not like it at all. Okay, chmod plus x, execdemo, sudo execdemo.bt. Can I not type my password correctly? That's really cool. arg0 can only be used with K-probes. Oh, interesting. Okay, that's fine. That's fine. That's fine. That's a good thing to know. Which means... Oh. Duh. I gave it. It's the C. Because it's command. Attaching two probes. So now... What did I forget? I forgot new lines. But check it out. We had our first BPF program, right? Simple. Nope, not what I wanted. Simple. Let's do new line there. Now, this is the command. I don't get the args because they're not there yet. And this is all getting executed by the user. And this is across the entire system, by the way, right? Because it's in the kernel. That's where this is getting pulled out of. Kind of wild to see, right? Just with a simple program. Okay, so now we have to learn a little bit more about variables. So there is an args, and we can convert it to a string. And if we go to variables, let's look for args here. Actually, this is exactly what we're trying to do, right? Args file name. This is basically what we're after. Almost exactly, right? So there's this built-in. Args. We have to convert it to a string. Stir. Stir. Args. And to learn more about what's going on there, we can do man to exec VE and understand how this works. What does that args struct look like? Can we find that? That's exactly where I'm going, GoPro. Yeah. Args built in. Built-in variables. Did I just miss it? Built-ins. Kernel level arguments. Here it is, right here. This is the args. The available members for each trace point can be released in their format file in /sits. So, oh, this is cool. This is cool. The available members for each trace point. So cat syskernel debug tracing events syscall sys enter exec VE. That's how we do it. That is neat. So if we want to learn about how this works, exec VE. Yeah. That's it. All right. So check this out. So we have file name, we have argv, which is kind of what you want, and then the environment variables. But we're going to try it with the argv. Yeah, because the argv, can you cast that to a string? I don't know, but we're going to try. So the file name is the executable, in this case, GoPro. And then, because remember that argv it's execve is the executable, right? Or it's the syscall. Then the first argument to that function is actually the executable. So it's not in argv as far as it's concerned. The program itself has argv coming in a little bit differently. But, so I want to see if we can just args, or args, yeah. argv. I can't imagine this is going to work, but we're going to try it. I'll be damned. It did work. Not really. It only sort of worked because C is C. It was more than happy to convert that those bytes into a string, but it's just garbage, right? That's really funny. So if we wanted to get all of the args, right, we would need to write a little bit of code to do that. So we have bash, we have the file name. Right, this is the command, and then here's the file name, and then any of the args, right? But args that are... There's a print format argument there. But I believe... Looping constructs. BPF trace supports C-style while loops. Interesting. Ooh, array access. You may access one-dimensional constant arrays with the array access operator. So, wow, okay. Boy, austere programming. So, we could do something like... A equals 0. Actually, I'm going to put that in here. And then while A is less than size of? No, because that's size in bytes. God, does C... I can't believe I have to... I don't write in C. Oh, it is size of. I was right. Okay. I don't write in C, so this is a whole thing for me. Size of args, argv. Now, I can't... The problem is that you can't mutate strings, right? Yeah, you can use stern cat to add a character to it, but you can't because strings are mutable in C. Duct tape was making sure I knew that the other night. Do we have tuples probes. At this point, you know what? I might be getting complicated enough that I'm doing actual C and not BPF trace. I should also mention that this filter, right, can actually be done here. I don't even need to do this conditional. I forgot to mention that. I don't even need that filter if I'm doing a BPF trace like this. Oh, wait, you know what? This is still going to work because of the nature of printf. Because I just need to not do a new line, right? Yep. It says we can do looping constructs, so I equals 0. Yeah. Works. And then printf. There is something to be said for writing code in such an austere environment. What is this song? There we go. Less than or equal to, I think. Right? Or is it less than size of? Less than. Because if it's 7 long, the last index will be 6. I've been programming for over a decade, and I still have to check that every time I run it. Unknown fudge's size of? Uh-oh. Well, that's tricky. Supports size of. That says it's done. It's listed here. Size of returns the size of argument space. Note that expression does not get evaluated. Returns size of the argument of bytes. The expression does not get evaluated. What are we running into here? Loops can be... All right, let's get rid of it and just see if we can hit the first argument. Right? Oh. Actually, I'm wondering if that might be the issue. If size of args argv const argv Here we go. So we're starting to structure this up so that this then be size. Still doesn't like size of there. Let's check our issues to see if it has some issues with size of. Something that I'm just missing. Build BCC 5. No. Zero 094. And oh no. I think it was added as 1.0. We don't have size of. That sucks. Boo. So, I mean, that actually proves the point, though. So at this juncture, right, even something as simple as this, BPF trace is starting to not serve our purposes. And what we might need to do is move over to using something like BCC, right, to compile. And the way that this works is we write the program in Python, and then right? Say from BCC import BPF. So we write the program in Python, and then we attach it. So this is a little bit more involved, but it's closer to what I think we're going to need in order for this to work, because we need to have some C stuff, right? We have now extended, even by just trying to get the arguments out of this thing, we're extending outside of what we have in BPF trace, because it is a pretty limited language. So let's see if we can take this as an example. And actually, I don't know why I closed that. I'm going to want that window open. And let's tab E into execview.py. Okay, so we'll import time, import sleep, and we'll want from BCC import eBPF. Cool. Let me just check to make sure that that's a thing. No. So BPFCC tools. Right, so this is the stuff that we tried. BCC installs surveillance. BPF FCC. Okay. So if that's true, BPFCC tools, Python, BFCC, and I think the others are installed. We just need the tools. Oh, it doesn't have Python BPFCC. Do we need Python 3? There it is. Hey, Owen. Neat. So now, import eBPF. Let's make sure that actually works. It doesn't. I'm gonna import eBPF from BCC. Did I get that wrong? I did. Import BPF. Much better. Okay. Fantastic. So now we're on our way to writing our first BPF program. So it basically goes like this. We start with B equals BPF, and then we give it, I believe, a multi-liner, right? Yeah. Where it goes text equals trip comments. Wait, are we just embedding C in Python? You know it. That is exactly how this goes. And the reason being, this is why eBPF programs are so wacky. They are compiled into their own thing known as eBPF bytecode before they are injected into the kernel. And so even if you look at the way that this is done in like Red BPF in Rust or the Go BPF libraries, they're all about wrapping C syntax one way or another. You can, Red BPF, I do believe, has a way for you to just straight write BPF programs in Rust, but then it handles the translation for you into the C that then compiles into the the limited BPF C that then becomes the bytecode. But even then, at that point, wildly, Rust is acting as a transpiler for the C that has to be written in order for BCC to compile it. There is no getting around writing C when you're doing BPF. Which I am still struggling with emotionally, because I have bounced off of C so many times. And I'm trying my best, but woof. Okay. So the way that this is gonna work, I don't think we need any includes here. I guess we'll need standard io.h, right? Is that right? Where's printf? Standard io.h. It's almost like I know what I'm doing, but I promise you I do not. By the way, so what did I just do with the man pages there? I went man printf, man 2 printf, man 3 printf. What's up with that? The man numbered pages have meanings. And depending on the thing, what do the numbers in a man page mean? Thank you, Unix Stack Exchange. The standard sections of the manual include. Yeah, fine. User commands, system calls for number 2. Number 3 are C library functions. So, and there's like system administration tools and daemons in 8. But if you're looking for C library functions, this is kind of cool, right? Because, Man. I want to play some Man because they're a great band from Philly. But they'll get me DMCA'd. No, I know the sections are in Man. Yes. Behold. And so for a lot of what we wanted, right? If we wanted to do man to exec VE, which is what we already did before, that's why it was in 2, because it was a system call. Okay, so right, so printf is the standard.io.h, so that's what we have here. So I think that's pretty much what we need. And then if we kind of look how this goes, there's a lot of cool examples in here, right? Tracing, byte hist, hello perf, Node.js stack snoop, strlen, task switch, TCP connect, random read. Is there any like exec? Because that would be nice. Hello fields. Oh, this is nice and simple. Let's try this. Oh, so from BCC utils import print b. That might actually be even better, because then we can do it in the Python. BPF trace print k hello world. Oh yeah. This is what we want. So what's cool about this is that rather than BPF trace, which kind of like runs the trace and has its own monitor for getting data out, by doing it this way, you can actually control the back and forth between the BPF program and what Python is going to run, and that's a little bit better. So what if we look at BPF trace print k, because there are these BPF helper functions. Right, it's a former to a printf compatible format string. Much easier. Yeah, BPF helpers. Thank you, Man7. Yeah. This is a print K-like facility for debugging. It prints a message defined by format. Each time the helper is called, it appends a line to the trace, which is what we are tracking here. So if we go, we'll write the program like this. I don't even need the printf because we're going to be doing the printf or the print stuff in Python, right? So it's actually much easier. We're going to pull some of this out, right? We're going to say PF trace print K. We do have to say, we have to define functions, so it's a little bit different. Do I need an int? No. I want to see... ptrace sched h struct data. So this is the trick, right? When you do it this way, you have to define the structs manually, which is a little bit rough, but we know how to do it, right? This is C++ stuff. We don't want that. Someone surely has... That's BPF trace. I don't want that. Oh, actually, I should be looking at the... This is the BCC reference guide, right? Args is from here. Here it looks like it already has args. Args are available in arg struct. Oh, I think we got away with it here. I think we might be in better shape than I thought we were. If we go to... We don't want the hello world exactly. Let's go back to our tracing. Hello fields. Right? So... let's take a little bit more of our... test. void context. And then BPF trace print K %s. Well, that's just saying I'm doing it anyway. Com like that, and then return 0. Then no semicolons at the end of Python lines. I mean, you can actually. So then we say b equals. Oh, we already did that. B dot attach probe. K probe. But actually, it's not what we want. We want b dot attach. Function name equals trace stack. So if we could go back to hello fields, how did this work? So the kprobe function name equals hello. The event though is attach kprobe. I swear that's not right. Because it's a trace point, right? We're talking about trace point probe. But that's in C. Oh, I don't want BPFC. I want... Is there like a Python reference? Attach, when using Python, the probe is automatically attached to the right trace point target. For C++, this trace point can be... argstruct can be used in place of CTX in functions. Context is already met. Whoa! I'm definitely feeling at the, edge of my zone of proximal development here, because there's a lot going on here. What I need is IPython. From BCC import BPF, and then can't get 9 type of bytes. Oh, fine. Ooh, didn't like that. Why not? Can't concatenate none typed of bytes. Oh, that was the first one. And then So we have a warning. Where was the error? Oh, print K. Oh, because prink is not a word. How about print K? Let's try that. Ooh, still didn't like that. Use of undeclared identifier com. Oh, interesting. So that is not just available to me. Oh, but BPF get current com is that's handy. Returns the first argument address with the current process name. Should be a pointer to a car array. Car com. Size task com length, which is defined in Linux sched.h. Okay, now we're getting somewhere. Now it demonstrates how much BPF trace was doing for us, right? Task, that was wrong. Task com len. Okay. And then BPF get current com. Yes. That worked. That compiled. Okay. Who would have thought it would be this much work just to get command line arguments with eBPF? Not I. Control Alt is block select? Whoa. Hold on a second. In what? In IPython? I'm trying. It's not doing anything for me. Seems like I've mostly killed something. So Control Alt. Oh, use your mouse to highlight? What? I don't know if that's gonna play well inside of Tmux. GoPro, does it? Does it honor the pane? That's the real problem. And that's why I was using the Tmux clipboard buffer. Should. Okay, Control Alt. And then use the mouse. Ugh. Yeah, that didn't look right. I mean, that's really cool to know, though. This is annoying, but the whole point, the whole reason I wanted to do this, was I wanted to see what B could do. That's what I wanted. Attach trace point. Right? Which we could have probably guessed. But nevertheless. And actually, Python PCC docs. I wonder if there is such a thing. PCC documentation. As a PDF. What on earth? No. Sometimes the Goog, I just don't know. Are you kidding me? Oh, here we go. I found BCC Python. It was in here. It was just hiding. Attach trace point. Yes, this is exactly what I want. This is an explicit way to instrument trace points. The trace point probe syntax covered in the earlier trace point section is an alternate method with the advantage of auto-declaring an arg struct. I definitely want to do that. Trace point probe. This is a macro that instruments the trace point. When using the Python, this probe is automatically attached to the right trace point target. Is there such a... So, actually, that's an important point. No. Trace point probe is what it's called, right? BCC dot. GoPro's got a video for me. Control Alt. So you're not even in. Oh, you were talking about Tmux being the mouse. I thought you were talking about IPython. But it looked like it was just Tmux there, unless that was... Yeah. Trace point probe. Okay, so tracepoint probe is it looks like, I swear it's a C macro. Oh, wait a minute. Okay, I think I understand what they're saying here. What they're saying is, if you use the tracepoint probe macro, in your code, you don't have to. So basically, we don't write a function. I think it's like this. I think they're saying tracepoint probe, and then the category and the event. So the trace point is enter, and then the event is exec VE in our case. And let's just do BPF trace print K exec, just to see if that works. And then is it okay? So from there, BPF b.trace fields. Okay, so then it's just wow, that might be way easier. So if we do while true, task PID CPU message. B.trace fields. Trace read line, trace print. I think I want trace print. That's cool though. B.trace print. And print F sleep 5. It's a good idea. Try all this. That is such an indentation, but okay. And then accept keyboard interrupt. Whoa. I don't have... I must not have my indentation set up right. I'm about to go over to VS Code for this. I'm tired of being cool. I'm annoyed that this isn't working. What is F? I had the same problem. Okay. But also, we're opening up VS Code, because enough of this. I love Vim. I do. But sometimes it's a little much. I am curious if there is such a thing as an eBPF syntax highlighter for BPF trace. It doesn't actually help me with this, but okay. 229 installs. Seems legit. Oh, I bet there is. Yeah, hang on a second. Let me just format this document here, because... Good lord. Are you kidding me? Yes. Do it. Oh, so much better. Okay. Now... I did all that and I forgot to solve the one problem I needed to solve. Okay. So that's, I would call that a good problem, because control failed to attach BPF program tracepoint enter exec VE to tracepoint enter exec VE. Is it sys enter? There's something we're not getting about this. It says, so this instrument is the tracepoint random urandom read tracepoint. And prints the tracepoint. Yeah. When using Python API. This program automatically searches the right tracepoint types. Tracepoint random urandom read. Oh, is it because it's not a trace point, but a syscall? Is that why? Okay. So if we go up to BPF, so BPF-C, KRAT probe, trace points, U probes, system call trace points. That's what we wanted. Syscall name is a special prefix that gets a... oh, it's literally this. Okay, so syscall exec VE that creates a kprobe for the system call name provided as the remainder. You can use it by declaring a new normal C function, then using Python, get syscall function name, and BPF attached kprobe to associate it. Ooh, okay, so that is a little different. Oh, okay. So we were closer than we were before. Or, we were closer before. So basically, we are going to need an int function. Right? We're going to need an int exec test. And this one takes args, which is kind of cool. So struct pt regs. Yeah. Right. Yes. And then something like, we're still going to do BPF trace print K hello, just to, or exec, just to see it happen. I'm also concerned that I have the context, I have the file name. I don't have argv. I don't have like com or anything. Oh, but we can get the current com. That's right. That's a function that we have. So in this case, it's syscall. Right. Syscall underscore exec VE. Yeah. With 2 L's, syscall is. And then we did our implementation. And then after that, we have to say, okay, we did the B equals BPF. Exec VE function name. Equals get syscall. Okay, so it's just this. And what are we doing here? So exec VE function name equals me.get syscall function name exec VE. Then we attach a kernel probe to the exec VE function name, whichever that happens to be. And then the function name equals syscall underscore exec VE. Okay, I think I get this. Okay. What'd I forget? I forgot a semicolon. What'd I forget now? Forward declaration of struct PT regs. Is it expecting us to have done something? Example in C2, search/tools. Kprobe for the system call provides the remainder. You can use it by declaring a normal C function using Python. Right, but is there a file name? I mean, that's right. That's the output. I don't want the output. I want the code. In syscall exec VE. What are we defining up top, though, that we need? Probably this, right? Oh, it didn't like that. At all. Control reaches end of non-void. Oh, Taggart, you doofus. Line 18. Okay. but implicit declaration of function BPF trace print, because it's supposed to be print K. We have a running BPF program at long last. Oh, Lord. Now, some interesting stuff going on here. Notice that I actually get the command for free, right? I get all sorts of stuff. So we actually saw this before in our hello fields, right? If we use the trace fields, we get the task, the PID, the CPU flags, the timestamp. For free too if we get the trace fields. So if we do this, right? But we want the message to have a little bit more than that. The whole point is we want the args, right? And so we have this argv. And this is finally where we get to do some of what we were doing in the in this. Right? We're gonna have to CFI it, but it's the basic idea. Yeah. Gonna put this junk in here. So I'm gonna say if size of argv greater than 0. Int. Well, wait, no, we could do for loops, right? We can finally do for loops in this, right? I'm not crazy. C has for loops. Yes, it does. Okay. I was like, so for int I equals 0, I less than int arg. What is the appropriate naming convention in C? Is it camel case or what? Can only have letters, digits, and underscores. Seems like it's snake case. argv I. Yeah. That's right. And then the whole point is that we're printing this. Separated by spaces, I guess. And then... What are you yelling at? Oh, right. This. And then... down here... We're going to print out... the... task. Actually, we're going to do the timestamp. Task followed by the message, which, if I've done this correctly, the print K is going to, like, add stuff to the string, but it's not going to give us a new line. So this will give us the full message. Nope, I messed up. Y. Int I equals 0. How about that? What now? Implicit decoration of function stir. No, I don't want... That is a BPF trace thing. I can't convert to... Dang. What is argv, though? Parconst argv. Oh, well, beautiful. I don't have to do it at all. Never mind, because they're characters. I don't have to mess with it. I just can say argvi. And I think I'm 1 paren too deep. Yes. Actually, frankly, no. I still want the space in there. So. Okay, so it's kind of working. It's just that it's giving me every argument in turn. Interesting. Interesting. We have some bytes there. Those are the key. Those are like just key codes, right? This is going to take forever. So it's like, it's kind of working. But the thing is, we still want... print K. For getting each argv, but oh, it's so funny that it's the byte strings too. So it's like we need the task. The task is a byte, so we're gonna is it decode or encode? Every time I forget, decode the bytes. Yes, good. And then same message.decode. What else do we have in the BPF helper functions? Print K. Lake facility. Prince can take up to 3 additional. Each time the helper is called, it appends a line to the trace. Lines are discarded while... Oh, I want one that doesn't append a line. Print K is slow. It should only be used for debugging purposes. Got it. Ooh. So I think that instead... What do you think the best way to do this is? Data output. Okay, so we got trace, perf submit, ring buff output, ring buff submit. What is ring buff? Nothing. Submit custom event data to user space. Must be received by a called ring buff reserved. Reserve space to the data. Okay, not really what I'm super interested in. Perf submit. It's a BPF table for pushing out custom event data to user space via perf ring buffer. It's the preferred method for pushing per event data to user space. Okay, so this is the deal. BPF perf output events. Events.perf submit. Where the hell is events defined? Events. Oh, I see. It's just creating a variable called events here. This is the preferred method for pushing per event data. And then struct data, data.pid. That's kind of interesting. Struct data. Data.com. Oh, look at this. So this is actually really close to what we're about, right? So we don't care about the PID because we're getting it. Events.perf submit. Right, and then we should be able to get the perf data. Oh, okay. So this is, I see where we're going here. So now we need a struct. Struct data. And the args are going to be something like that. Not quite. Oscar user. C people, I need your help. How do I define a struct that contains an array of essentially strings. Because we have the const car user. Who is it? Is it something like that? Because that's kind of what we have down here for the definition. No, because I have to find the length of the arguments. Maybe that's what this user is. I honestly don't know because I'm out of my C depth here. Hey, Digital Warhead. Yeah. This is actually really close to what we wanted. The problem is... Here we go. Const argv. Okay, so kind of close. I wasn't totally nuts. Const argv. Okay. Yeah, and that's what we're pulling it from. Oh, and actually, would that have helped me out here? 100%. This is what I should have been thinking of. Const argv. Okay, assuming this works. And that's just, what are they calling that? They're just calling it argv. Yeah. Okay, so now got myself a struct here, and what we want to do with it is the whole idea is we want to no. Come on. Perf output. Right, so we want to do BPF perf output events. And that's actually outside of the int call, right? And then here, we're not even going to loop. We're going to grab just this. Events dot argv. There's a space missing here. Events.argv or events.perf submit. No. Okay. So it goes data.args equals argv, and then events.perf submit, and we submit context, right? That's where we're sending it. And then we're sending it the data struct reference. And how much are we sending? We're sending size of data. And then return 0, right? Yeah. Now, the question then becomes, how do we get data out of it? Which is more like this. So b dot perf buffer pull. Pull and open perfering buffers, calling a callback. Calling the callback that was provided when calling no. Perf buffers attach prevent. So that's the next question, is how do we see this actually happen? And this is hello perf output. So this is actually close to what we want. Is this thing? Yes. So perf output. Print event. Open perf buffer. So okay. So it is kind of like this. So we want to print the event. Global start is 0. Start equals 0. Timestamp. Loop with callback to print events. I see. So so it is open perf buffer. It's just that we need to basically create a if print events, and we're gonna give it a message, I think. Yeah. And then B events. Interesting. Open perf buffer. And then while true, or I guess it's a single event, so it should be print event. And then while true, b.perf buffer pull. And if we look at what was coming in, it was CPU data size. CPU data size. And ooh, interesting. Okay, so this is kind of non-arguable because these are data size. So event equals b events dot event data, whatever the data happens to be. And then start equals 0. Start equals event.ts. Oh, interesting. Print event dot argv. Yeah. We get rid of this. True. All we do here is b dot perf buffer poll. Use of undeclared identifier data. Expected identifier or I feel like I forgot to declare something important here. Yes, I did. I forgot struct data. You're correct. There is no such thing. Data.argv. Okay, now what? Oh. The car const is not recognized. Please define with C types manually, which would make sense, and that I think was the error that they were getting. Const car const v. Include Linux BPF.h. Let's do that. And get this thing to run tonight. Wow, adding that made it way worse. Or at least changed it. So field has incomplete type. I may require the rest of the includes, which is BPF helpers. Interesting. BPF helpers not found. Take these out. Right, so car const not recognized. Please define the data types with C types manually. See, this looks okay. Const car. Yeah. Const car, const RV. Now, is that where it's freaking out? This is type const car const star not recognized, which is definitely that definition. Please define data types, C types manually. Oh boy. Oh, interesting. Right. This is a Python error I'm getting. Please define the data with C types manually. So yeah, we have to use C types. God, I haven't done this in a second. Or ever, really. Yeah, we still have to do something with it. Ugh. I have some more C to do here. I didn't expect to get this far down into C. Just to print out argument names. Kind of wild. User file name. Pointer. This is a great pointer. I don't want that. So the real question is, why doesn't this thing have to do it? Because it's just doing car com. Because it's not doing anything like that. We search for const car. Anything could be in here? Oh, yeah, it is. Okay, so... These are C++ files. Not quite. Give for free value. All right, I have some more work I need to do on this. But as you can see, there's a lot of potential here, but also a lot of work to do. And with any luck, we can actually pull off some cool stuff, but it's been a long stream, and I need to get going. So sorry to end on kind of an off note tonight, but we'll have some fun on Saturday. We'll come back and do some more Blue Team stuff on Saturday at 10 a.m. Pacific. For now, let's see if there is anybody else who's streaming. Ooh. The Gore appears to be online. Great. We will raid him. Alright. If you don't know about the hack list, make sure you check out all of the InfoSec streamers that are out there. And let's give the Gore a raid. So yeah. Apologies, it wasn't super exciting here toward the end, but I think there's some value here to be gleaned with a little bit more work. But yeah, we'll be raiding the Gore and be back on Saturday at 10 a.m. Pacific. So until next time, friends, please be good to yourselves, be good to each other, and happy hacking. We'll see you next time.